kilogram suitcase and acceleration of 2.2 meters per second squared to the right. Let me check something here real quick. Are we getting anything? All right. Yeah, let's try that a little better. So what force is required to give a 25 kilogram suitcase an acceleration of 2.2 meters per second to the right? So F equals ma. Mass is 25 and acceleration is 2.2. So this multiplied 25 times 2.2 is 55 newtons. Okay, 95 kilogram clock, that's the mass. Initially at rest on a horizontal floor requires a 650 newton force to set it in motion. So 650 newtons is required to just move it. That means 650 newtons of friction is your static friction, what's holding it in place. After the clock's in motion, horizontal force of 560 keeps it moving with a constant velocity. That means the net horizontal force is 0. So find the coefficients of friction, static, and kinetic. So coefficient of friction is friction over normal. So this static is 650 over the normal force, which is just mg because the clock's sitting on a flat surface. So mg is 95 kilograms times 9.8 or 931. So the static friction is 650 divided by 931 or 0.698 is the coefficient of static friction. Now the coefficient of kinetic friction is just friction. Oh, wait. 560 is required to keep it moving. So now we got to do a net force equation. So net force equals 560. Constant velocity is equal to the friction force. Okay, that's why. 560 is your friction force because it's moving at a constant velocity. So the net force of the whole system is 0. So friction is 560 and normal force is 930 because it's the same mg sitting on the same flat surface. And then that coefficient of kinetic friction is 0.601. Number 37, a 4 kilogram block is pushed along the ceiling with a constant applied force of 85 newtons. Well, this 85 act at an angle of 55 degrees with the horizontal as in the figure. The block accelerates to the right 6 meters per second squared. Determine the coefficient of kinetic friction between the block and the ceiling. Well, here is my coefficient of friction formula. Put a square around that. Yeah. And so my friction force, let's see, we got to think about this. On a horizontal, the net force, this equation right here would be worth looking at. Let me get that centered up. Okay. So that means my right facing force is 85 times cosine 55. So this is an 85 Newton force. And we need the horizontal part, the horizontal component. So 85 times cosine 55, which is 48.75 newtons pushing to the right. So F net, which is a 4 kilogram mass at an acceleration of 6 meters per second right here. 4 times 6 is 24. So my net force is 24 newtons right here. Okay, so net force is 24, and my right facing force is 48.75. So minus the left facing force, which would be the friction. Well, we got to figure that out. 24 is my net. 24 equals 48.75 minus friction. So if we add friction to both sides and then subtract 24, 48.75 minus 24 is equal to 24.75. So my friction force of the kinetic, of the moving part, 24.75. So now we just have to figure out what the normal force is, because remember that my mu is friction over normal, and the net force on the vertical is 0. That means force, all the forces up equals all the forces down right here. Okay, so let me erase this over here. This looks a little crazy. Okay, so write this in red. F net is force up minus force down. The net force vertically is 0. So that means force up equals force down. So we've got an up force 85 times sine 55. This is an upward force provided by the push, the 85 Newton constant at a 55 degree angle. So 85 times sine 55 is 69.6. And mg is 4.9.8. 4 times 9.8 are 39.2. So we've got one of the ups and one of the downs, but the last one is the normal force. So let's figure this out. Up 69.6 equals down, which is 39.2 plus the normal. So 69.6 is equal to 39.2 plus the normal, and we subtract 39.2 from both sides. 69.6 minus 39.2 is 30.4. So our normal force is 30.4. So now we take friction force, which is 24.75. Let me write this in a different color. Let's see here. Hang on. Get my pen. Friction force, which is 24.75. Let's write it in this bright blue. And we'll write it in that size. Oh, wait. Back up. Okay. So here we go. So friction force over normal force. So mu equals friction over normal, which is equal to 24.75 divided by 30.4. And if we travel way over here, we got that right here. So 24.75 divided by 30.4 is 0.814. And there's no units because both those other things were newtons and they canceled out. Okay, so there's your two coefficients of friction. Number 39, 925 crate. That's mg, by the way. 925. That right there is just mg equals 925. Okay, so just keep that in perspective. This is not mg. Okay, so it's being pulled across a level floor by a force of 325 newtons at an angle of 25 above the horizon. Coefficient of kinetic friction between the crate and floor is 0.25. Find the magnitude of the acceleration of the crate. Well, let's see here. This 325 is being pulled at a 25 degree angle. So we've got a horizontal component and a vertical component. So we take 325 times sine 25 to get the vertical component. And we take 325 times cosine 25 to get the horizontal component. Okay, so, and we know that the coefficient of friction is 0.25. So coefficient of friction is friction over normal. So 0.25 times the normal, right? Coefficient of friction times the normal would equal the friction force. And that means our friction force is equal to 0.25 times 787. My normal is 787.65. Now, how do I know the normal is 787.65? Because the normal force is not equal to mg. 925 is mg. And the reason I know it's not equal because we've got an up force pushing right here, which is 137.35. And that plus the normal force is equal to 925. So we're going to subtract. This is the original equation right here. Okay. So that was our original equation. 137.35 up equals 925 down, right? Mg is down, minus 137.5. Well, that minus wasn't in there. So 137.5 up, right? Plus the normal force up. These two are ups equals 925, which is down. So now we subtract 137.35 from both sides. Normal force is equal to 925 minus 137.35, which is 787.65. All right, so my normal force is 787.65. Now we can kick it in up here. Friction force, which is 196.9, divided by normal force, which is 787.65, equals, wait, we don't need to know that. That's where we got 787.65. Sorry, that's what I meant. So 787.65 times 0.25 is equal to friction force, which is 196.9. So now we can look at the net force equation and say, okay, I've got a net force equation horizontally speaking. I don't like that at all. Let me try and reframe that. So net force equation, there we go, is equal to force right minus force left. So the net force equals some number. We don't know. So 294.96 is this number. This is the horizontal right. Right 294.6. That's 325 times cosine 25, right? Because that's the right facing force on this box from the 325 at 25 degrees. We have a horizontal component and a vertical component. We got the vertical already. Horizontal is 294.6. And we're going to subtract 196.9, which is our friction force, which is pointing back this direction. So this is our friction. So friction force right there. That's going to be that left-facing force. So right-facing is 294.6 minus 196.9 is 97.7 newtons. That's equal to MA. So we can do that little equation right there, which is Newton's second law, and make that thing work. So we take 97.7 newtons divided by the mass. And how do we get the mass? Well, we took 925, which was the given right here. 925 was the given. Oh, why won't it let me? Never mind. 925 is the given, mg. So we had mg, and we took that divided by 9.8, which is g. Subtract, divide both sides by g. So m is 94.4. So 97.7 is your average, your net force, equals m over a, or m times a. So divide both sides by m, 94.4, and a is 1.036. All right, last one for now, and then we'll do a separate video for the others. A 2 kilogram mass starts from rest, and slides down an inclined plane 8 times 10 to the minus 1 meters long in 0.5 seconds. Well, that's 80 centimeters, so 0.8 meters, and the time is 0.5 seconds. What net force is acting on the mass all along the incline? Well, this would be easy if we knew the theta. So theta right here, if we knew that, we could just say mg times sine theta would give us the force pushing it down the hill, this one, the incline force. And like I said, if we knew theta, that'd be sweet, but we don't. So now we got to go about it the other way. And we say, well, it took us half a second to go 80 centimeters or 0.8 meters. So then I just plug it into this equation right here. And I say, okay, distance is equal to 1/2 AT squared plus V initial T. Well, V initial is 0. So that's nothing. Nothing left there. Okay. So D is 1/2 AT squared. So 2D, multiply both sides by 2. 2D dividing by both sides by T squared. 2D over T squared equals A. So 2D is 1.6 meters divided by T squared, which is 0.5, times 0.5, which is 0.25. So it's equal to 0.64 meters per second squared. And there you have it.